Welcome to this video. I am the teacher from Ilm Online Academy, and in today's video the topic is about the chemical calculations. This is basically the chapter number 5 of the ongoing series for the chemistry revision notes 0620, and in today's video we will be having a look at the chapter 5, which is about chemical calculations. So further ado, let's just begin and let's talk about the contents which are included in chapter number 5, which is about the chemical calculations. So the contents which are included in chapter number 5 and which we will discuss today, first is about the mole and the Avogadro's constant. Second is about the mole and the chemical equations, and the third or last one is about the moles and the solution chemistry, which we will discuss today in today's video. So further ado, let's just begin. And first of all, you should know about stoichiometry. So let's first answer yourself on what is stoichiometry. Stoichiometry is basically about the measurements. So this is the ratio of the reactants and the products that are present in a balanced symbol equation of any chemical reaction. So stoichiometry is basically about the measurements or the chemical calculation that are present in our chemistry or also in the chemical reactions. So for this you should know about some definitions that are present in our chapter, and the first one is about the moles. As the mole is the amount or the quantity of the particles which is fixed for any substance, and the 1 mole of a substance has a mass that is equal to its relative formula mass in grams. The RAM, which we discussed in our previous video in the chapter number 4, RAM, the relative atomic mass, the relative molecular mass, and also the relative formula mass in the grams, the amount of a substance that contains 6.02 into 10 raised to power 23 particles that are present in that substance. This is the Avogadro's constant, or the amount of particles or amount of atoms, molecules, or formula units that depend upon that substance that is considered. So this is about the mole. The simplest definition of mole is the quantity or the amount of the substance that are present there, and the number 6.02 into 10 raised to power 23, that is known as the Avogadro's constant. These are the number of particles that are present in 1 mole of a substance. So the mass of 1 mole of a substance is known as the molar mass. Molar mass is same just like the molar mass is same as the atomic mass, relative atomic mass AR, and the relative molecular mass of any substance. So the simplest definition for the moles is this, and the unit that is used for mole is mol. Let's remind about the molecular formula and the empirical formula which we discussed in our previous chapter. The molecular formula is the actual number of atoms in a molecule and the actual number of atoms of each element that are present there, and empirical formula is the simplest whole number ratio of the atoms of each element that are present in any molecule or in any compound. Like for example, we have the molecular formula of butane is C4H10. This is the molecular formula, and the empirical formula for this one would be C2H5. This is the empirical formula, which is the simplest whole number ratio of the compound that are present there. So these are the definitions we should know about the moles, the molecular formula, the empirical formula, and also about the Avogadro's constant. Next, we'll talk about some formulas that are related to this chapter or that are important there. So the first formula which we will discuss today is about the moles. The mole, that is the unit for the amount of substance, and the simplest formula, the formula triangle for the mole is like this. We have, that is the molecular mass or the molar mass. MOL is the mole. So this is the formula triangle for the relationship between the amount of substance mole, the mass that is present, that is in grams, the mole that is in, that has the unit mole, and the molar mass or the molecular mass that has the unit gram per mole. That can be used to calculate any calculations that are related to the moles. Molar mass is same just like the relative molecular mass and numerically, but the molar mass has a unit gram per mole, whereas a relative molecular mass is a unitless quantity. The relative molecular mass of calcium is 40, but the molar mass of calcium is 40 gram per mole. So the simplest formula for calculating the moles is moles equals mass in grams over molar mass. This is the simplest formula for calculating the moles, and this is the diagram formula triangle for the calculating the moles. Moles equals mass over molar mass, and for calculating the mass, what you will do, you have to multiply the moles with the molecular mass. So you can adjust the formula with which you want to find out which quantity with this molar mass. So for calculating the amount of substance, we have the formula, which is amount of substance moles mass divided by molar mass. We have an example related to this. Calculate the amount of a substance in 42 gram. So now we have an example. We have to calculate the amount of a substance in 426 gram of sodium sulfate So for calculating this, they gave us the mass. The mass is here, the mass that is present in the grams. So for calculating the molar mass, we have the formula. From the formula, you can easily calculate the molar mass. As I already told you in our previous video about the relative molecular mass, relative atomic mass from the periodic table. You can easily check from the periodic table the relative atomic mass of any element. So for the sodium, we have the relative atomic mass, that is 23, as there are two atoms of sodium in sodium sulfate, so you have to multiply it with the 2, and then you have to add it with the mass of the sulfur. The mass of sulfur is 32, plus we have the mass of oxygen, which is, as 4 oxygen atoms are there, so you have to multiply it with the 4 into 16. So after calculating and after simplifying it, we have the molar mass, that is 142. 142 is the molar mass, and the formula unit is gram per mole. The mass is given in the question, so for calculating the amount of a substance, you just have to put these values in our formula. Moles equals mass is 426 and the formula mass or molar mass is 142. So by dividing 426 with 142, we have the amount of a substance, which is equal to 3. So 3 moles of Na2SO4 is present and 426 gram of sodium sulfate. So this is how you can calculate the amount of a substance. For calculating the mass, you can use this formula for calculating the mass, moles into the molar mass. And also you can also calculate the molar mass of any substance. So for calculating the molar mass, we have the formula molar mass. Just by substituting with this formula, you can easily get these values. Molar mass equals mass divided by moles. So by this, you can easily find out the molar mass. This is how you can find out the molar mass of any substance. Next, we have the relative atomic mass or relative formula mass. So for calculating the relative atomic mass, you can use the same process or the same formula that is used for the molar mass, because relative atomic mass, relative formula mass is same as the molar mass of any substance. Next, we will calculate the number of particles by using the value of the Avogadro's constant. As you know that the Avogadro's constant contains the number of particles that are 6.02 to the 10 raised to power 23, and the amount of a substance are the number of moles. So for calculating the number of particles that are present in any substance, you can easily do it by this one. So for calculating the number of particles, we have the formula. So this is the formula for calculating the number of particles in any substance. Number of particles equals Avogadro's constant, and then you have to multiply it with the moles. The example here will be, you have to calculate the number of carbon dioxide molecules in 1.5 moles of CO2. So the example here is, now we have to calculate the number of particles or the number of carbon dioxide molecules in 1.5 moles of carbon dioxide. So by applying here this formula, we can easily get the answer. Number of carbon dioxide molecules equals Avogadro's constant, and the value of Avogadro's constant is 6.02 into 10 raised to power 23, and you have to multiply it with the moles which are given in our question. Multiply with 1.5. So after simplifying it, we have the answer, which is 9.03 into 10 raised to power 23. So this is how you can easily find out the number of particles from this formula. This is how you can find out. You can also find out the moles from this formula if number of particles are given there. So this is about the moles. So next we will discuss about the concentration of a substance. Now we'll talk about the concentration, and the concentration of a substance is the amount of solute that is dissolved in a measured volume of solution. So concentration can be calculated by the formula. There is a specific formula that is used for calculating the concentration. Concentration has a specific units. The unit for the concentration are mole per decimeter cube per dm cube, or we have another unit which is gram per dm cube that is used for the concentration. Concentration is the amount of a solute that is dissolved in the measured volume of a solution. To convert between the two units, the mass need to be converted to the moles or vice versa by using the formula triangle that involves the molar mass, moles, and the mass. You can change between these two units just by doing this one. So we have the concentration. Concentration can be find out by using a formula, and the formula for the concentration is, concentration equals amount of a solute that is added in a solution over amount of or volume of solution. The amount of a solute that is calculated in grams, and the volume of solution that we will calculate will be in the decimeter cube, that is the unit of the volume. So when a chemical substance or a solute is dissolved in a volume of a solvent, we can measure the quantity of solute in two ways. We can measure either its mass in the grams or its amount in the moles. So that's why we have two units for the concentration, and the final volume of the solution is normally measured in the cubic decimeters. And 1 decimeter cube, this is the hint, 1 decimeter cube is equal to 1 liter, and that is equal to 1000 centimeter cube. So you can easily switch between these different units. 1 decimeter cube equals to 1 liter and 1 liter is equal to 1000 centimeter cube. We can measure the mass of the solute in grams, that is mass concentration, that we can obtain in gram per cubic decimeter cube of the solution, and we have molar concentration, that is mole per decimeter cube. Mole per decimeter cube is the molar concentration and gram per decimeter cube is the mass concentration, because mass is present or mass is required for this one. The mass concentration of a solution is measured in gram per dm cube and the molar concentration of a solution is measured in mole per dm cube. When 1 mole of a substance is dissolved in water and the solution is made up to 1 dm cube or 1000 decimeter cube, a solution with a concentration of 1 decimeter cube will be prepared. 1 mole per decimeter cube solution will be prepared when 1 mole of a substance is added in 1 dm cube of water and the solution is made up to 1 dm cube, and now a solution with a concentration of 1 mole per decimeter cube is produced. This is how you can find out the concentration of any substance that are present there. So concentration, we have some calculations of the concentration by using the solutions, like these are the some equations that are useful when we work out the number of moles present in a particular solution. For example, the formula will be the number of moles that are present in any solution is equal to molar concentration and then you have to multiply it with the volume of the solution, and the volume of a solution is always measured in dm cube. So this is the formula or the mathematical equation that can be rearranged to work out any unknown value provided the other two values are known, and it can be represented by this formula triangle. This is the formula triangle and you can easily find out the other two or the unknown one value that is provided if the two values are known. So we have moles here and concentration that is divided by 1000 if volume is present in centimeter cube. If volume is in centimeter cube, then you have to divide the concentration with the 1000. If volume in decimeter cube, then it's not required. So if the number of moles, for calculating the number of moles, we have the volume. If the volume is in centimeter cube, then you have to divide it with the 1000. But if it in decimeter cube, just skip this. So for moles, concentration will be divided with the 1000 if the volume is in centimeter cube. These are the two formulas which are usually used for dealing with the solutions that are present in cubic centimeter cubes and in cubic decimeter cubes. For example, how many moles of sugar are there in, this is the example for this. How many moles of sugar are there in 500 centimeter cube of 3 mole per decimeter cube solution? So in this example, as you can see here, we are given with the solution volume 500 centimeter cube and we have concentration that is 3 mole per decimeter cube is the concentration of this sugar solution. Now we have to find out, the concentration is given, the volume is given, we have to find out the moles. For calculating the moles, what we will do, we have to apply this formula, the above formula. 500 is this volume that is multiplied with the concentration that is 3 and you have to divide it with the 1000 because the volume that is given in the question is in centimeter cube. So after simplifying it, we have the answer, which is 1.5 moles. So this is how you can find out the concentration, the moles, also the volume of any substance if two values are known and the other one is unknown. So now if we have a calculation involving the gases, up till now we have done the calculation involving the solutions or the solvent that are present there, but now if you have calculations that involve gases, so for that, so now we have calculations that involve the gases. Use the molar gas volume that is taken as 24 decimeter cube 24 decimeter cube at room temperature and pressure, or RTP, equal amounts in moles of gases occupy the same volume under the same conditions of the temperature and the pressure. Volume of 1 mole of any gas at room temperature and pressure is 1 decimeter cube. So this is the volume of any gas at room temperature and pressure at 1 mole. So for calculating, we have some formula diagrams or triangles through which you can easily calculate the volume in dm cube. If the volume is in dm cube, so for that what you will do, we have here n and 24 decimeter cube. This is how you can easily find out the volume of the molar volume or molar gas volume. If the volume is in centimeter cube, we have volume in centimeter cube equals, and here you have to do it with the 24,000 centimeter cube. So this is how both the triangles are same. The only difference is spotting whether the question uses the centimeter cube or the decimeter cube for the volumes and also for the molar gas volumes. So for this one you can easily find out the molar gas volume for the calculations that involves the gases. So this is how you can easily find out for the gases. This is the volume of the gas that is present there, and if the volume is in centimeter cube you can use this formula. This one is the molar volume, and n represents the number of moles that the gas occupies. So this is how you can easily find out the 1 mole of any gas occupies a volume of approximately 24 decimeter cube or 24,000 centimeter cube at room temperature and the pressure, and the molar gas volume of any gas therefore has the value which is 24,000 centimeter cube or 24 decimeter cube. This rule applies to all the gases. This makes it easy to convert the volume of any gas into the moles or moles into the volume. So you can use the formula for calculating also the moles. You can easily adjust the values. Moles equals volume over molar volume. So this is, through this formula you can easily find out the moles of the gases. So in this equation the volume is in decimeter cube and the molar volume is in 24 decimeter cube per mole. The calculations here are, for example, we have the example of this will be, if we have 8 gram of sulfur that is burnt and you have to find out the volume of SO2. When 8 gram of sulfur is burned in the air, in excess of air, then we have to find out the volume of sulfur dioxide gas that is produced. So for finding this, for considering the reaction of the sulfur, we have to consider the reaction of the sulfur that is burning in the oxygen. Sulfur reacts with the oxygen that is present into the air, and then it will produce sulfur dioxide gas that is SO2. Through this equation you can find out, or you can say that 1 mole of sulfur reacts with 1 mole of oxygen to produce 1 mole of sulfur dioxide gas. 1 mole of sulfur has the molar mass, that is 32 grams, and 1 mole of oxygen has the volume, as this is a gas, so the volume will be 24 decimeter cube, and 1 mole of sulfur dioxide that is produced, that is also the gas, so we have 24 decimeter cube of the volume of sulfur dioxide. So from the equation we have these values. Sulfur dioxide is the gas, so the volume is used. Oxygen is also a gas, but sulfur is present in the solid form here. So these are the symbols for physical states. So we have the formula, that is, for calculating this we have to find out the formula. Moles equal 8 gram, that is the mass. Moles equals mass over molar mass. This is the first formula from where you can get the moles. The moles will be 0.25. So now you have to apply the formula for calculating the number of moles equals volume over molar volume. This formula, now we'll apply this formula, moles equals volume over molar volume, for calculating the volume of the sulfur dioxide. For applying in this formula, we first know the moles, so we calculate the moles by using the formula moles equals mass over molar mass. So by applying in this formula, we have moles equals volume over molar volume. The moles are 0.25 and the volume, we will find this is the unknown value, and the molar volume for this one is 24 decimeter cube from the above equation which we have done right now. So after multiplying 0.25 with 24, you can get the volume, and the volume will be 6 decimeter cube at room temperature and pressure. So by using this relationship between the volume of a gas and the number of moles it contains, we can easily find out the volume of any gas at room temperature and pressure. Now we'll talk about the calculations or calculating the stoichiometric reacting masses that are present in. Now we'll talk about calculating the stoichiometric reacting masses that are present there. For example, we have the example with the calculate the mass of the oxygen that is needed to react with 24 gram of magnesium. So the example for this one will be 24 gram of magnesium react together and it will form magnesium oxide. 24 gram of magnesium react together and form the magnesium oxide. So we have to calculate the mass of oxygen. Mass of oxygen will be calculated. How much mass of oxygen is required? So we have to calculate this. So this is how you can calculate the stoichiometric reacting masses. Oxygen is the reactant, magnesium is also the reactant, and it produces magnesium oxide, that is the product. So we have to calculate the stoichiometric, the related to measurements or the calculations that are present there, and the reacting masses that react together to form the product. So the equation, chemical symbol equation for this one will be magnesium will react with the oxygen gas as the magnesium ribbon that react with the oxygen gas, and it will produce magnesium oxide. So first we will balance this equation by writing in the coefficients. Identify. So first of all, you should know about which formula we'll be using here. So the most simplest formula will be mass equals mass over, we have molar mass and we have moles. This is the formula triangle that we will use here. We have mass in grams, molar mass, and also the moles. Moles can be calculated by dividing the mass with the molar mass. Mass can be calculated by multiplying the molar mass with the moles. So you can draw the multiply here and division will be here like this. So for calculating the mass, you have to divide the mass with the molar mass, and for calculating the mass, you can multiply the molar mass with the moles. The first step for this question will be identify which formula you will need to use. Identify which formula you will need to use in this. First, identify the chemical symbol equation for this one. The second step will be find the molar mass of the oxygen. Since the molar mass of the oxygen is finding the molar mass of oxygen. The atomic mass of one oxygen atom is 16 here, and through this equation you can check that oxygen is present in the diatomic form, so the molar mass of or molecular mass of oxygen will be 32, as the atomic mass is 16, so 16 into 2 we have 32. This is the first step. Second, you have to find out the molecular mass of magnesium. So first you have to find out the molecular masses of the reactants that are present in any chemical equation. So for the molecular mass of magnesium, as you can see here, two magnesium atoms react together here in this equation. For the one, the mass is 12, but for 2, as 2 is present in front of the magnesium, it is not it is present there, so you have to multiply the 12 with the 2. Now we have 24. This is the molecular mass of oxygen and magnesium. Next step will be finding the moles of the magnesium, and moles of magnesium will be done by dividing the mass with the molar mass. Mass of magnesium with the molar mass. The mass of magnesium is 24 and the molar mass is also 24, so the moles of magnesium that react together are just 1. Calculate the moles of oxygen also. We can calculate the mole of oxygen by using the balancing of the numbers. If 2 moles of magnesium, so from the chemical equation you can check that from the chemical equation 2 moles of magnesium react together. If 2 moles of magnesium equals 1 mole, 1, so according to that 1 mole of oxygen will be 0.5. So from the balanced chemical equation you can easily find out the moles of the oxygen. So now we'll calculate the mass of the oxygen, that is the required one. Here you can see that we have to find out the mass of oxygen. So the mass of oxygen is calculated. The formula for the mass will be mass equals molar mass into moles. The molar mass of oxygen is 32 and the moles are 0.5 as we done from the balanced chemical equation. So this one will be 16 gram. So 16 gram is the mass of oxygen that is required to or needed to react with 24 gram of magnesium to form the magnesium oxide. So this is how you can easily find out the calculate the stoichiometric reacting masses that are present in the chemical equation. Now we'll talk about the calculations related to the limiting reagents. So we have limiting reactant. A reaction will finish when one of the reactants are all used up. That reactant is known as the limiting reagent or limiting reactant, and it determines how much product is formed in that chemical reaction. The other reactant that is left over and that is in excess. So by working out the mass of the limiting reactant, we can determine the mass of the product that is produced from that chemical equation. For example, if you have 0.96 gram of magnesium, 0.96 gram of magnesium reacts with 2.19 gram of HCl, and when both of these react together they form a product that is known as magnesium chloride and hydrogen. So now we have to calculate what mass of magnesium chloride is produced. What mass of magnesium chloride, MgCl2, the mass of MgCl2, what will be produced? So first we will check which one is the limiting reagent or limiting reactant. So for that we have some steps. The first one, work out the moles for both the reactants. The first step is finding the moles for both the reactants. For the moles, you can use the first formula, moles equals mass over molar mass, the simplest one, mass over molar mass. So the first step is mass over molar mass. So you can easily find out the moles of both. So by putting the values in this, we have the moles of magnesium are 0.04. You can do this. We have the moles for hydrochloric acid will be 0.06. So this is the first step for calculating the limiting reactant or the limiting reagents from any chemical reaction. The second step of this will be use the molar ratio of the reactants to determine which one is the limiting reagent. Molar ratio, you can check the molar ratio as magnesium ratio hydrochloric acid, as these two are present in our chemical equation. So from the equation we have magnesium plus hydrochloric acid react together and they form magnesium chloride, MgCl2 plus hydrogen. So from the equation you can check the molar ratio of the reactants to determine which one is the limiting reagent. So we have MgCl2. So this is the balanced equation. So from the equation you can check that 1 magnesium 1 ratio 2. 1 magnesium and 2 hydrochloric acid react together and they form the magnesium chloride. So according to this 1 ratio 2, 1 mole of magnesium produces 1 mole of magnesium react with 2 moles of hydrochloric acid to form the magnesium chloride. So according to that we have, as we have done with the moles in the previous first step, 0.04 ratio 0.08 moles, but there is only 0.06 mole of HCl, so 0.08 moles of HCl, so hydrochloric acid will be present there as the limiting reactant. Now you have to divide it with the molar ratio. After dividing it, what will happen? So by comparing the moles, you can easily check which one is the limiting reagent. So from the equation, 1 mole of magnesium react with the 2 moles of hydrochloric acid to form the magnesium chloride. So we have find out the moles for the magnesium 0.04, and then after that, after multiplying it with the simplest whole number or the ratio of the atoms that are present in the chemical equation, we have 0.16 moles of hydrochloric acid. So HCl is present in as a limiting reagent. So for that, hydrochloric acid is present as the limiting reagent. These are the steps that you will follow to find out the limiting reagent. First, work out the number of moles. Second, divide each by its balancing number or the coefficient in the balance symbol equation. And third or last, the simplest number indicates the limiting reagent that is present in any chemical equation. So this is the hydrochloric acid is the limiting reagent, and we can find out the mass of the product, which is the required one. So the mass of magnesium chloride will be mass equals moles into molar mass. So 0.03 are the moles of magnesium chloride. You can find out the moles by doing this one. It's 0.16. Using the molar ratio of the limiting reagent and the product, you can find out the moles of the product as hydrochloric acid. With the ratio we have MgCl2. Hydrochloric acid has the ratio of 2 and MgCl2 has just 1. So 0.16 ratio 0.06 ratio of moles of hydrochloric acid with 0.03. So moles will be multiplied with the molar mass, and the molar mass of magnesium chloride is 95. You can easily find out from the periodic table, and the mass of this will be 2.85 gram. That is the required one in this question. So now we'll talk about the acid-base titrations. The titration is a method of the quantitative analysis using the solutions. One solution is usually added to a known volume of another solution using a burette until the endpoint is reached. The concentration of an unknown acid solution can be found if it is reacted with the standard solution, and this method is known as a titration and can be adapted to prepare a soluble salt. So for the preparation of the soluble salt, you can use the method of titration. So for calculating the titration from the experimental data, from a titration can be used to calculate the concentration of the or volume or moles of a solution by using the formula. And for that we have the triangle. For this one, number of moles, concentration, and this one is the volume. So for the titrations, you can use the formula moles equals concentration into volume. For titrations, you will require to convert between the decimeter cube and the centimeter cube. For the converting decimeter cube to the centimeter cube, you have to multiply it with the 1000. And for converting centimeter cube into decimeter cube, we have to divide it with the 1000. This is how you can convert between the centimeter cube and the decimeter cube. Next, for example, if we have 25 centimeter cube of hydrochloric acid that is neutralized by 20 centimeter cube of a base, and the concentration is 0.5 moles per decimeter cube, that is of base, that is used NaOH. So now we have to find out the concentration of the acid. The volume of the acid is here and the volume of base, and the concentration of base is given, but now we have to find out the concentration of the acid. Concentration of hydrochloric acid, HCl, the first step will be, for calculating this, we have to convert the volume from centimeter cube to the decimeter cube for applying the formula. So 25 centimeter cube will be, by dividing it with the 1000, now we have 0.025 decimeter cube. And for NaOH we have 20 centimeter cube, and after that we have 0.020 decimeter cube. This is the first one. You have to convert the volume from centimeter cube to the decimeter cube, and next we'll work out the moles for the NaOH, sodium hydroxide moles. For the moles, you can use the formula moles equals concentration into volume. Concentration will be multiplied with the volume. The concentration is given, that is 0.5, and the volume of NaOH is 0.02. After simplifying it, we have 0.01 moles of NaOH that is used. This is the third step. And the third will be work out the mole ratio by balancing the chemical equation. So according to the chemical equation, hydrochloric acid react together with sodium hydroxide NaOH to produce NaCl salt, plus we have water that is produced there. So 1:1 is used according to the balanced chemical equation. So the number of moles of hydrochloric acid will be equal to 0.01, as the molar ratio of both the acid and the base are equal. Now we'll find out the concentration, and the concentration will be done by using this formula, moles divided by volume, and then you have the concentration. So the moles are 0.01, and the volume that is given is 0.025 in decimeter cube. So the answer will be 0.4 mole per decimeter cube. So that is how you can find out the concentration or the moles, or you can also find out the volume that are according to the acid base titrations. So this is how you can find out this one. Next we'll calculate the percentage yield. So the formula for calculating the percentage yield will be, for calculating percentage yield, we have the formula actual amount of product produced divided by the theoretical amount. So actual amount of product that is produced will be divided with the theoretical one, and you have to multiply it with the 100. Actual divided by theoretical, so just because of the percentage, so you have to multiply it with the 100. So this is how you can calculate the percentage yield by using this formula. For calculating the percentage yield, it is not always possible to obtain the theoretical amount of the product, because the reaction may not go to completion. It is reversible. Some of the product may be lost when it is separated from the reaction mixture. Or third reason will be, some of the reactants may react in different ways to the expected reaction. So for calculating the theoretical yield, you can find the mass by molar mass into the moles. So this is how you can find out the theoretical yield and also the percentage yield. Next we have the percentage mass by composition. Percentage mass can be calculated by this formula. Percentage mass equals the total relative atomic mass of the elements that are present in that compound with the molecular formula of that compound. And just because of percentage, you have to multiply it with the 100. So this is how you can find out the percentage mass of any element in the compound. For example, you can calculate the percentage of magnesium into the in magnesium carbonate. You can work out with the molecular formula of the compound and then atomic mass, and input your data into this equation, and you can easily find out the percentage mass. The next is about percentage purity. So for the percentage purity, you have the formula for percentage purity. We have the formula: mass of the pure substance is divided by the total mass, and then you have to multiply it with the 100. This is the formula through which you can easily find out the percentage purity of the substance. It is possible you will need to calculate the mass from the moles first. For example, a solution of sodium chloride contains 0.64 grams of NaCl. 0.64 grams of NaCl is present in 100 grams of water. So you can calculate the percentage purity of mass of NaCl by this. The mass is given here, the total mass is given 100, so by multiplying it with 100 and applying or putting all the values in the above formula, you can easily find out the percentage purity of any substance. So percentage purity can be calculated by the mass divided by the total mass and multiply it with the 100. So percentage purity of NaCl will be 0.64, and with the total mass is 100, and you have to multiply it with the 100, so the answer will be 0.64 grams, 0.64 percentage. The percentage will be the unit for the percentage purity, for percentage mass, for percentage yield. So all for these we have the percentage unit that is used for this one. So this is all about the percentage yield, percentage purity, percentage mass of all the compounds, or you can easily find out the percentage purity, mass, and also the percentage yield of any substance by using these formulas. So from the experimental data, you can put the data or input your data into these equations, and then you can easily find out those from these above formulas. So this is all about the chapter number 5, which is about the chemical equations, or chemical, you can say that the chemical calculations. We have till now we have done with the moles, we have done with the number of particles, we have done with the limiting reagents or the limiting reactants, the concentrations, the calculation that involves the solution concentrations, and the calculation that involves the gases, acid base titrations, the limiting reagents or the limiting reactants that are present there. And also we have done with the percentage of by mass of an element in a compound, the percentage purity, the percentage yield. The percent purity and the percentage yield of a product from a chemical reaction can be calculated from the theoretical yield from the equation, and the percentage by mass of an element in a compound can be found from the relative molecular or the formula mass. And the concentration of a solution can be expressed in mole per decimeter cube, and these values are useful for calculating the results of the titration experiments also. So this is all about today about the chapter number 5, which is about chemical calculations. Hope you enjoyed it. We'll meet in the next video.